Connect, collaborate, discover. Transforming research and education networks to the power of N. I'm Kate Winn, Head of Executive Communications for the Network Infrastructure Group at Nokia. And this is Reconnect, where we dive into today's finest research and education networks in the company of some of the great minds behind them. Today we're looking at Sikt, Norway's NREN organisation, which delivers more than 80 products and services for up to 1.5 million active users per day from over 700 different organisations. The Sikt NREN community is involved in exciting scientific research, such as tracking whale movements in the North Sea via undersea fibre optical sensing. Sikt has a long-standing relationship with Nokia, which is providing the technology to support the transport of these massive data sets. Today, I'm joined by Sikt's Kurosh Bozorgbrahimi, Senior Advisor for Optical Networks at Sikt. Kurosh has been involved in numerous research and development projects within optical access, fibre optic sensing, and transport networking. And also with us is Alberto Bellato, who is a technical project manager and network architect from Nokia's Network Infrastructure Group, and whose focus lies in the technological aspects of telecommunications environments and network scenarios. Let's jump right in and find out more about these exciting projects. So, Kurosh, these marine and terrestrial optical networks, they're supporting really incredible research.
Yes, Sikt is running the Norwegian National Research and Education Network, and one of our major tasks is to support scientists and the research activities in Norway. As part of this task, we provided the necessary physical infrastructure and instruments to help scientists to accomplish their goal. Sensing possibilities are opening a new area of services and insights in the geophysical domain and expand the use of deployed optical fibers. Through many field tests with different sensing techniques and also deployment scenario, we have learned a lot about the sensing possibilities as available technologies. So, back 5 years ago, we knew very little about sensing, but through all these activities, testing, playing with different techniques, so we learned a lot.
Can that research actually benefit our lives on dry land?
Sure. The use cases are quite many, while the live monitoring monitoring of the environmental parameters, temperature, pressure, and many other things, and detecting the seismological activities. To understand the changes will help us to understand the cause of it and the parameters related to these changes, actually. So the question is, can this information benefit our lives above the surface? Certainly. This information will directly actually affect our life. Optical networking equipment should be designed to transport not only the ordinary data traffic, but also more advanced services like time and frequency and sensing application. We should also aim for advanced AI-based analyzing tools, help operators to interpret the parameters using for sensing, also for performance. Regarding the current optical transceivers, phase and polarization changes are already getting detected. To improve these features actually in the current transceivers and combining them with a powerful analyzing system will give us 2 worlds of sensing and data transfer through the same hardware. Will expand the use of current receivers actually. We have been working with CGF, Center for Geophysical Forecasting at NTNU since 2020, and from 2023 also in SubMERS project. SubMERS is an innovative EU-funded project which aims to utilize existing submarine cables already used by the research and education networking community to monitor the Earth and its system. The project, a collaboration between 24 partners, will collect data from sites in Norway, Portugal, and Greece and make it available to a diverse group of research communities, thereby creating a highly collaborative environment. Regarding the test activities in Norway, we are using both commercially available sensing devices, but also using so-called prototype equipment. We run these activities both in the lab and in the field on dark fiber, but also combined with optical line system from Nokia. We are aiming to do a field trial with Bell Labs and also of Bell Labs advanced transceiver-sensitive prototype. This system also aims at prototyping future transceiver sensing capabilities. The testbed at the Svalbard is excellent for this test because of the interesting environment combined with reference instrument, both polarization sensing and also distributed acoustic sensing. This is of crucial importance because several implementation aspects will determine sensing performance with transceivers compared to tail-rod instruments. In addition, actually, also we aim at performing loop-back measurement with the aim of understanding the potential and the limitation of polarization-based sensing with localization. And this activity will be run in collaboration with Nokia Bell Labs.
What would you say is the next phase of this research?
We are in the early stage of optical sensing area, using already deployed optical fiber communication infrastructure. Also, optical fiber sensing have been existing for many years, but the unique one is that combining it with already deployed optical fiber communication infrastructure. The final goal should be to create a kind of worldwide sensing network, which can help scientists to access the research data instantly, but also to deliver it to them on their desktop. Of course, within the frame of security regulation, but all in all, the benefits of using sensing for monitoring the environment and climate changes are huge, both for mankind and also for planet, actually.
Alberto, let me turn to you for a minute. What's the optical networking solution used in Sikt's subsea network to power these research projects?
Nokia is providing to Sikt what is commercially available in terms of photonic transmission system and transport and transponder, optical transponders. As a transmission optical engineer myself, let's say it's amazing to see this kind of new frontiers of the research being applied only for data transmission. This kind of research can be supported with the current systems, basically letting full availability of what our systems can deliver. I would say that there is not, at least from the pure photonic point of view, there is not a very particular performance requirement, unless, let's say, for the DAS based sensing, for example, where an external specific equipment need to go into the fiber. The challenge was to be prepared to have this kind of access, because this is not a traditional feature that we deliver for data transmission. While for, let's say, the sensing base, and that's really I believe the ultimate frontier, the analysis of the SOP, so the state of polarization, there instead we have to provide, as optic division, the coherent processors that allows not only to transmit the data, but also to interpret how the signal is running over the fiber and understand upon the environmental influences how the signal has been perturbated in the transmission. Understanding that perturbation, then we can be able to understand what is happening in the environment.
So you're talking about pretty advanced photonic and digital signal processing technologies. Explain to us a little bit more about what makes those so clever.
Well, yes. So basically, in transmission, and we are talking about the, let's say, the so-called coherent transmission, which allows, let's say, the very high capacity transmission over the fiber. It changes status. So the ability of our systems, so the coherent detectors, is to measure these, let's say, these perturbation and understand how to recover, of course. So now with the technology we have, we can collect how the signal is impaired during its own transmission. And then with the aid of software processing and machine learning and ultimately artificial intelligence, we can understand let's say, the impairment, and we can be able to detect what is the so-called fingerprint of that impairment and understand what is happening. So whether the fiber is underwater, so we have maybe, okay, the passage of ships, passage of fishes, big fishes, of course, or how current are going, but this kind of application can be also in terrestrial networks. And the coherent state of polarization detection, let's say, can have a very, very big impact in building the network sensing all over the world. So it is really widely open to whatever we can think. So the future on this area, I believe, is really, really bright.
You've been working together in the optical networking space for some time. What's next for the partnership?
Yeah, from our perspective, to be able to have network equipment which enables a self-protected, self-driven, and also robust optical network at the same time supporting advanced non-data services are important. To be able to work together to form the equipment is the key for a good and fulfilled relationship.
So indeed, we provide let's say, the equipment for transmission to Sikt. This kind of application now opened the door to, let's say, a next phase of application and research. Research also from our side, because working with Sikt, we are learning that a network system is not only for that application, so for transmission application, but also to go beyond. And I really believe this beyond is the next phase and the next life, let's say, of telecommunication infrastructures. And so this kind of research is, let's say, helping us to build systems that are able also to understand, let's say, the environmental conditions around us with what was classically used only for bit transmission. So that's the most exciting part of, let's say, these kind of projects, and we are working, let's say, to proceed, of course, this cooperation together.
Thank you so much to both of you. I'm afraid that's all we have time for to discuss this inspiring work. But thank you very much for joining us. To both of our guests, Kurosh Bozorgbrahimi and Alberto Bellato. I'm Kate Winn. Thank you for listening. It's always amazing to see how customers are using networks to unlock new research and discoveries. If you'd like to learn more about the RENs we've discussed and the technologies behind them, visit our website. Next time on Reconnect.
I recently visited the Nokia office in Singapore, and I was thinking of 400 gig. You were showing me 800 gig. I'm totally blown away by that.
What's unique is really this diversity, right? It makes it really interesting. But what you have also is kind of a level of complexity, right?
There is a need how to orchestrate, the different NRENs network together.
You've got each countries need to kind of upgrade or modernize their infrastructure, right? But each of those countries needs to interwork together.